Presentation, the study of boric acid as lubricant in metal forming and studying its friction and wear behavior. As you all know, metal forming can be termed as a backbone of production or manufacturing, and it has a plenty of application throughout the world. The main objective of metal forming is not only to produce components or devices, but also to ensure its minimum tooling cost, minimum loss of material, and so on. Hence, in order to achieve this, a clear understanding of the tools to be used, the processes to be followed, and also the various parameters and various properties of the material should be known. Continuous contact between workpiece and the tool results in friction. Friction is a major problem associated in metal forming, and lot of prevention and measures should be taken in order to reduce friction. Friction also has a significant effect on the surface finish, metal deformations, etc. Hence, in order to reduce friction and wear in metal forming, use of a lubricant is very much necessary. Lubricant is a material which is used to reduce friction between the tool and the workpiece. The different types of lubricants which are used today are dry, semi-dry, and viscous. Powdered is in the form of dry, grease is a form of semi-dry, and oil is a form of viscous. Over the years, a lot of attention and research has been done in order to reduce or substitute the hazardous lubricants which are obtained from crude oil. Green lubricants. As the name itself relates its nature, its relationship with the nature. Green lubricants are one which are obtained from vegetable oil or which are naturally available. They optimize energy efficiency and they have no harm on the health or human beings or the nature. Okay, the research question which would be answered in the following presentation is: if the boric acid lubricant could be used in all metal forming processes effectively, and also to study the effect of different boric acid additive size on cannel oil and its friction and wear behavior. Okay, boric acid. This is a schematic diagram of a boric acid in its interstellar solid form. The main properties of boric acid is that it is available readily, it is non-toxic and environmental safe. So in this topic we will be stretching on the use of boric acid as a lubricant. So these are some of the tests which are available to support my research question. So this is how I will be answering the research question or the design. So first one is a drawing test. The main objective or principle behind drawing test is to draw the work part or the work piece between the punch and the die. So this is the punch and the die, and by applying drawing force here, the material gets deformed. So and it gets the shape of a cup. So these are the parameters which are used in the experiment. The aluminium is used as a material. A circular blank of dia 85 mm was reduced to 0.2 micrometer centerline average. The punch dia was maintained at 50 mm. The punch speed was kept at 0.067 mm per second. Cylindrical flat punch were used. Once the material was prepared, it was polished using a grit paper in order to obtain a good surface finish, and so on. Along with boric acid, other lubricants such as oleic acid, molykote, Teflon, graphite oil, and others were used as a base for comparison. Once the experiment was performed, the drawing force was measured. So this graph shows the drawing force required for various kinds of lubricants. So as you can observe, the drawing force required in the case of no lubricant condition is maximum compared to the other. In the case of boric acid, the drawing force is the least. So we can conclude that boric acid lubricant requires the least drawing force compared to the other lubricants. So boric acid can be used in various metal forming operations compared to the other. The one more experiment which supports our research question is the effect of different size boric acid additives on cannel oil. Boric acid was milled using a milling machine. All the particles were put in the milling machine, and based on the time the milling process was carried on, various types of boric acid were obtained. Microscale boric acid size, average size 4 micrometer was obtained when it was run for around 6 to 8 minutes. So based on the time the milling was carried on, different sizes were obtained. Sub-microscale, the average size would be 60 nanometer. in a mixture of microscale and sub-microscale is a combination of both. Nanoscale will be obtained when the milling is carried for a very long time, and also in addition to it 5 micrometer MsO2 powder was also used as additive. Once the boric acid was milled and obtained, it was mixed with cannel oil. We have used cannel oil because cannel oil is one of the environment friendly lubricant which can be used along with boric acid, which will have a greater result in the researchers to follow. So this is a diagram of a pin on disc apparatus. We place the lubricant which are to be tested in this part, and this is a rotating disc with certain dimensions. 4 ml of each lubricant was applied in the rotating disc. On the pin on disc apparatus, 4 ml of each lubricant which was produced was applied on it. A sliding velocity was fixed constant at 120 mm per second, and a load of 100 gram was kept constant. Friction was measured for a sliding distance of 7,500 mm. For every 7,500 mm of each lubricant, the friction force was measured. At the end of the test, a microscope was used to study the pin morphology. So, in all the cases for each lubricant, whatever values were obtained were plotted in the form of a graph or a table. So, this graph shows the sliding distance versus coefficient of friction. The square is for the 4 micrometer boric acid, the circle is for 60 millimeter boric acid, a triangle is for the mixture, and inverted triangle is for the 5 micrometer MsO2, and so on. So this graph clearly indicates the coefficient of friction force required for the material. So from the result obtained, among all the lubricants, the 20 nanometer boric acid proved to be the best, and based on the frictional performances, it was followed by MsMOS2. The reason for this was the low friction was due to the colloidal solutions between the molecules. Also, the 20 nanometer boric acid additive was one of the best wear. So 20 nanometer gave us the best result for the wear and also for the friction. So hence, among the different sizes of boric acid, it would be better to use the 20 nanometer size additive. Conclusion: the boric acid along with cannel oil is used as a lubricant in metal forming operations to replace the crude oil based products. Limitations: only using boric acid without any additives was found to be ineffective for sliding tests that were performed, and also boric acid when used for longer durations was not very much active. So boric acid can be used only for shorter durations, which should be taken care of, and also with some other lubricants which are to be followed. Thank you.